Hello. So, we will be talking about basic definition and implications of similarity. Our definition of similarity is that two figures are similar if one is simply a blown up and possibly rotated or flipped version of the other. Blown up, by the way, is just another word for dilation. So, the most important things to note from this definition are that the corresponding angles in similar figures are equal. Hence, we have AE equal to, or angle A equal to angle E, angle B equal to angle H, and so on. If you notice, they're in corresponding positions. And that the ratios of the lengths of the corresponding sides of similar triangles is always the same. In similar quadrilaterals, it also works. So, we have the following ratios. They're all equivalent to each other. AB over EH, well, that makes sense because those sides seem to match up. BC over HG also makes sense. CD, GF, again makes sense. DA over FE makes sense. But then we get to AC over EG. So we have AC and EG also being in this same proportion. And we have that BD over HF also would be an equivalent proportion. This is why the triangles are so important. Now, what does this mean? Well, if we have a problem like this, where it says given that ABC is similar to YXZ, which of the statements is true? Well, first one is AB over YX. Is that equivalent to AC over YZ? Well, we notice that AB and YX are corresponding sides, which is good. And AC, sorry, C is here, AC does also seem to match up with the YZ. So that would mean that our answer is true. Okay, now let's look at part B. We have that AB over BC is equal to YX over XZ. Now this is a little different because they're using one ratio with the same triangle and the other ratio with the other triangle. But if we use the logic we used before, AB matches with the other triangle, AB matches with XY or YX. And we know that must be equal to the side that BC matches up with, BC over XZ. BC over XZ. And if we do some cross multiplication, we get that AB times XZ is equivalent to BC times YX. That's just basic cross multiplication. And from there, if we divide one side by BC, this side here, divide by BC, and divide over here by BC, and at the same time we can divide over XZ on both sides, we would get the following ratio. So the XZ's over here cancel out, and we would be left with AB over BC. And that would be equivalent to, well, the BC's over here cancel out. We have YX over XZ. And what do you know? We get our exact same answer from part B, so I know that that is true through basic multiplication. And in the next video, we'll be figuring out the other parts to this problem.